MongoDB. You can download MongoDB from mongodb.org or .com, and you should already have this installed on your local machine and already have configured in MLab. And we verified this on our first assignment, right, to make sure that indeed you had your database connected to your application. So I'm not going to go over that. I'm going to assume that you already have MongoDB already installed on your local machine and also on your remote MLab instance. Now, locally, if you run MongoDB locally, I'm assuming if you're on a Mac, you're just running sudo mongod, or on a PC, probably you can just type mongod and it'll start the server. And that's what I have here. I have MongoDB running and listening at the particular the port, the same port as always, 27,017. That's the default port. The installation of MongoDB and the bin directory that you should all have on your path, right? That's how you start MongoDB. On that same bin directory, you also have another executable in there called Mongo. So Mongo is the out-of-the-box client. It's a text-based client that you can interact with the database. It connects to MongoDB, and you can ask it things such as, show me all the databases that you currently have. These databases are being stored in that /data/db directory that you had to create early on. Remember that? That directory is where you have all these databases stored in there. And I have quite a few. These are from several semesters I've been teaching, and so we're going to create one for this class, and I'll call it. You can say use. I'll call it webdev _ summer 1 2017. Okay, but if you show DBs, notice that the database is not actually stored here. It's not shown here as being listed. It's because we haven't yet interacted with it. We haven't inserted anything. There's nothing in it. And so, excuse me. To be able to store information in there, you need to interact with it. Insert data, create instances, right? And to do that, you use the db command, db, to interact with the database, and then dot the collection that you want to interact with. So in SQL, we talk about tables, right? We break out our information into tables. Tables have columns. In Mongo, we don't call them tables. We call them collections, right? Since tables have a very particular meaning, right, in the SQL world, we use another term. We're going collection of object instances, which is the synonymous to being a table of records, right? Here we call them a collection of object instances or collection of documents, where each object instance we refer to it as a document. Okay, so we don't call them records; we call them documents, right? But they are the equivalent, right? The only big difference, right, is that a record denotes that there is some schema associated, right? That a particular record matches a particular schema for that table, right? So you create a table and you give it a schema that I want. This has to be a varchar, this has to be an integer, this has to be, and so on and so forth, right? Over here we don't have that. There are no schemas, right? Each document can have its own schema. Not that you would want to do that, but nothing is stopping you from doing that, right? So, for instance, if I want to create a to-do list, you might create a to-do. So that's the name of the collection. So db.todo, it doesn't exist, right? We're about to insert data into that collection, but you don't have to explicitly create the collection. Just by inserting an object into it, it creates the collection for you. Right? So it'd be db.todo, the collection that you want to interact with and you want to insert into it. Notice that the syntax is very object-oriented, right? As opposed to a pseudo English interaction as insert into table name, right? And presumably should have been made it easier for human beings to interact with a computer. But this is just as fine for us programmers, right? It's a object-oriented syntax. And then in here you have a JSON object instance that you want to insert, and you might say that the to-do insert might have a title, okay, and this might be pick up kids, right? And maybe it has a date, okay, and might have a 2/17. What is today? 06/05. Is that today? Yep. And notice that it comes back saying that there was one document inserted. Now that it actually has inserted, you can query the database saying what collections are there. Just like in MySQL or some of these, you can ask it to give you a list of all the tables that are in there. You can do the same thing here. You can say show collections, right? And it tells us that we only have one collection in this current database, and it's just the to-do collection, right? Just like you can insert. Well, let's insert just another one. So this would be grade assignment 3. Okay, so we have two documents that we've inserted so far, right? You can query it and say, well, what's there for now? Right? You can say db.todo, and there are a couple of ways to query it. You can query it if you know the exact ID of the object, or you can just find and show me the entire list of things that are currently in that collection. Notice that when we inserted it, we never gave it a primary key, right? We never gave it a unique identifier for any of these records, but that by default is given the responsibility to the database. The database, if you don't want to deal with it, by default the database will choose a primary key for you, right? As opposed to in SQL, you might have to explicitly say how to create the primary key, whether there's a sequence or does it do an auto increment. Here by default, it just always picks the primary key for you. Right? You can override that and say, no, I want to handle that. Right? So by the default is to just let it do its thing and pick its own primary key. Okay. So find, this is the this is kind of like the basic way to find everything, and it takes as argument a filter. So this is kind of like select star from to do, retrieve everything. Yes.
When you say pick its primary key, I assume that it just picks one field, right?
No, it creates a brand new field.
Okay.
It creates a brand new field. Yeah. So if we do a find, we see that here's a piece of information that we added earlier. The title, the date, right? And notice that there's a brand new field, right? Underscore ID. You should recognize that field, right? We've been using it on the client side, and then when we moved it over to the server, right? And it was deliberately we chose the underscore ID, right? So that it's forward compatible. All the code that you've written so far, hopefully, will be forward compatible with MongoDB, right? Assuming that that was the name of the primary key. Notice that it's underscore. Anything that starts with an underscore is managed. It's a field managed by the infrastructure, right? You might sometimes see other fields in there that, especially when we start programmatically interacting with it, right? And those other fields are for MongoDB's internal maintenance, okay? When it tries to index your database to increase performance, so it has its own managed fields which you should not interact with. You should not update or manipulate in any way. You can read them, but you should not try to modify them. Okay. Notice that this field has a particular data type. It's object ID. Right? Internally, it has its own representation on how to interpret this. Right? It's this unique identifier, right? And it's internally it uses to also be able to index this for quick retrieval. Notice that it looks as if these two objects have the attributes or fields, title and dates, right? And as far as we know, that might be a schema, right? That both records, not records, documents, have the same fields, title and date. But nothing is stopping us from inserting something and by accident, right? We don't remember what the field was and we say label instead, right? And we insert it. And the database doesn't balk at this, right? Because again, there is no schema, right? I can find everything, and I still have two records that look like they're following a schema, and some error that this one is not following the same schema, okay? And Mongo will not validate this since there is no schema whatsoever. It's the responsibility of validating all this is going to be on the application level as opposed to the database, right? We're going to have to move this to the application, and that's okay. We're going to be using a library that does this for us, right? That does the validation for us. So at first, this might seem like chaos for those of us that come from the SQL world, but it's it's as if you're running a Java program for a very long time and you're using RAM to store all your data. Yes. You're going to do validations anyway, right? For all the data that's going to and from the client and your own application. So again, don't think of this as a relational database. It's storing objects permanently, right, in memory for later retrieval, right? Okay. All right. So we updated this, and just like you can find. You can also provide a filter, right? If you provide a parameter in the finder method, you can tell it to filter only those that meet that criteria. Okay, so you might say that only the one that has a label that matches this particular label right here. Okay, and notice that it returns just one. Now, if you see that it's returning lots of information, and perhaps this object might contain a lot of information, lots and lots of attributes with very long pieces of data, you can append to this a filter. There are many filters, right? .pretty is one of them. That just represented in an easier way to read it, just one property per line. But there's quite a few other ones. You can do a sort, you can do an order, you can do all sorts of filters, and you can string them together. We will do that a little later. All right, so find. So we call these finder methods, right? Finder methods. .find. If you don't provide an argument, it just retrieves all of them. If you provide a filter, right, or a where clause, this would be the where clause, it would return only the ones that match all the attributes that you put in here. Okay, all the attributes. Now, this is matching exactly, so label needs to be exactly this, right? But there are other operators that allow you to say greater than, less than, like, okay, or in an array, just like you would find in SQL, right? This one is an exact match. And we'll get a chance to play around with all those operators a little later. Okay. All right, so that's fine. There's also being able to update something. That's for instance, and the command is .update, and update again allows you to provide a where clause. Right. I want to update only that one, right? Only that one record document. Right, you want to update that one document, and you can then provide a. Oops, sorry. You can then provide a second argument of what do you want to do with that document. Right. So, for instance, I like to set. Right, set allows you to notice that it starts with a $sign. Right. So this is not one of your attributes. Right. This is a command that is part of the framework, a library of commands. Here we are setting the following attribute, right? Notice that I have I have a title that is grade assignment 3, and label is also grade assignment 3. So I'm going to change the label to be grade quiz 4. Oops, sorry. I'm sorry, you have to tell the field label and then set it to a new value. Yes? So this is the values, the new values of the field, and this is a set command, and this is the update command, right? So if I do that, it tells me a status information telling me that there was one match, right, and there was one that was modified, right? There's an additional command that we're not going to look at right now, but it's where you upsert meaning find it. If you find it, update it. But if you don't find it, then insert it, right? Which is a very common use case from a programming's point of view, right? It's very, very convenient, right? So find it. If you find it, return it, right? Or update it and then give it back to me. Or if it's not there, if you don't find it, then insert a brand new one with this data that I gave you. Okay. So if you do a find again, if you do a find and a pretty. Notice we have the first two that have a title, and the last one, notice that it was modified. See, it says label grade quiz 4. Okay. The data types that we're using right now here, these are all strings, but all the native JavaScript data types are supported. So number supported, dates, functions. You can store functions as well. All right, so let's see. We did create, being able, so the CRUD operations, but the there's only 4 operations, right? You can create new data, you can find existing data, you can update existing data, or you can remove. And to remove, you can say db.to, and then you can say remove. Now, unlike SQL, if you do a remove like this, and by mistake you run and you don't give any arguments, it's like doing a delete from a table and you don't give it a where clause, right? The default is to delete everything, right? The default here is not to delete anything, right? Is to, if you don't tell me what to delete, by default I will not delete anything, right? So be careful. If you do give it a where clause, don't give it an empty where clause, because this will remove everything. Okay, so we're careful there. So if you do this remove, you can give it a filter and say, well, which document do you want to remove? It says, well, I want to remove the one whose label is now the grade 4. Right, so let's grab that. And let's paste it in here. If we do that, it says, yes, 1 was removed. And if we do a find again, notice that document is no longer there. Okay? Or like we did earlier, right? If we by mistake, right, we do a remove and we don't give it any arguments, then indeed it'll remove all the records from there. And if you do a find, there's nothing there. Right? If you want to drop the entire table, which is somewhat common when you're doing a lot of development and you have a lot of changes in schema you haven't yet decided, you can just drop the entire table, which is just calling .drop, and it will remove it. Right? If you try to remove it again, it'll say no, there is no such collection. Right? Everybody okay? These are very, very simple commands just to get us started. Right? We'll introduce new commands as we need them. All right. So the interesting part is really being able to interact with this from programmatically from our code. Right. So let's play around a bit to do this programmatically from JavaScript. All right.